The gunner's thumb is numb from yanking the charging handle, but he can't stop. A German half-track has just nosed into the orchard lane, and the first cannon round walks across the road like a ruler. The men in the ditch have seconds. The only thing between that vehicle and a broken line is a long, ugly block of steel. A Browning M 2.50 caliber. The gun doesn't sound like a machine gun. It sounds like a door being kicked in, over and over, slow enough to count, hard enough to feel through your teeth. The tripod shudders, the barrel smokes, and when the gunner leans into the spade grips and presses, the world in front of him changes shape. Leaves explode. A fender folds. The half-track hesitates, not because it is dead, but because someone has finally made it expensive to keep moving. By the end of the story, you'll know why the M2's weaknesses, its weight, its old-school controls, and its demand for careful setup became the very reasons it dominated battlefields. The secret wasn't only caliber, it was a system that made a heavy gun available, feedable, mountable, and fixable when everything else broke. Exhibit A is the mechanism. The M2 is recoil-operated. When it fires, barrel and bolt recoil together a short distance. Then the barrel is stopped and the bolt continues rearward, extracting the case, cocking the firing system, and advancing the belt. It is simple in concept and forgiving in practice. Big parts, plenty of mass, and timing that stays stable when grit, cold, or rough handling try to steal reliability. People fixate on the cartridge like it is the whole verdict, but the cartridge is only the witness. What mattered was that the M2 could do many jobs without becoming a different weapon. On the ground, it could suppress beyond rifle distance and reach into hard cover. Against light vehicles, it could break radiators, shred tires, and chew thin armor. Mounted on trucks, it became a fast answer to ambush. Mounted on armor, it became a high-angle solution for rooftops and tree lines. That flexibility carried a cost, and it's the M2's most famous demand: headspace and timing. Headspace is the distance between the bolt face and the cartridge when the round is chambered. Timing is when the gun releases the shot relative to the bolt's position. If those are wrong, you get misfires, torn cases, and, worst, an out-of-battery event that can wreck the gun and injure the crew. Early procedures required crews to set headspace and timing after a barrel swap. Critics called it awkward, crews called it insurance. The gun didn't ask for genius, it asked for discipline. A crew that could follow a short checklist could keep the weapon predictable. And because the parts were robust, the gun rewarded correct setup with sustained reliability. Perfection wasn't the point. Availability was. Heat makes the lesson sharper. A .50 cartridge dumps serious energy into steel. Under hard firing, the barrel heats fast, and when a barrel overheats, you lose accuracy, accelerate wear, and invite stoppages that look mysterious, only to crews ignoring physics. So the M2 forced operators to think in cycles. Controlled bursts, brief pauses, belt management, lubrication, and if the mission demanded it, a barrel change done right. The weapon's rhythm wasn't style, it was survival. Now anchor it in one real slice of war. Late summer 1944, a narrow French road lined with hedges, and a truck column trying to push fuel and artillery shells forward before dark. Movement is the mission, because every stopped vehicle becomes a target for mortars and artillery registration. A scout vehicle up front takes fire. Drivers brake. Engines idle. The column compresses into a knot. The first danger isn't the bullets, it's the traffic jam. A jam creates a clock, and a clock creates panic. This is where the M2's weight becomes a strength. A lighter gun is easier to carry, but it won't do the same work on hard cover. The .50's practical effect is not magic tank killing. It is that it forces relocation. It chews firing slits, splinters hard corners, and punishes the exposed pieces that keep an ambush alive. Hands on triggers, eyes behind gaps, tires on a getaway vehicle. It makes a hedgerow feel thin. In a convoy fight, forcing the shooter to move is often more valuable than chasing a perfect kill. Exhibit B is the mount. A pinel mount on a truck is not glamorous engineering, but it is unforgiving. It must absorb recoil without loosening. It must traverse smoothly without binding. It must let the gunner keep sights on a gap in the hedge while the vehicle shakes and men shout. If the mount fails, the gun becomes dead weight. The M2's recoil impulse is predictable enough that training turns into control. Exhibit C is the support chain. The M2 was produced in huge numbers and supported with spares. Springs and extractors could be replaced without a machine shop. Belts could be staged and linked with routine. That matters because a heavy gun's real enemy is friction in supply and maintenance. When a weapon becomes something armorers can service and quartermasters can feed, uptime becomes a tactical advantage. Here's the misconception to cut cleanly. What people get wrong is thinking the M2 mattered only for destroying targets. The correction is that it shaped behavior. It created no-go lanes for infantry. It punished exposed movement. It forced vehicles to button up. It made just peek and shoot a losing habit. In a war of constraints, shaping behavior is often the same as destroying equipment, because it changes where and when the enemy can act. By the end of 1944, the M2 wasn't just a weapon, it was a network. Ammunition, mounts, drills, and maintenance routines tied into one ugly promise. When the enemy tried to make movement impossible, there would be a .50 somewhere close enough to make that attempt hurt. And the next part turns on a question that sounds small until it breaks everything. When the shooting didn't, so the crew's problem wasn't courage. It was math, measured in belts, heat, and seconds. If you fire them M2 like a movie, you lose it. If you fire it like a machine, you keep it. That's the first quiet rule the gun teaches. The real rate of fire is the rate you can sustain without cooking the barrel, starving the feed, or exposing the team. The gun can cycle fast, but the position can't survive fast for long. In that French lane, the gunner learns this by feel. He presses for a long burst and the muzzle climbs a hair. The tripod shifts. The beaten zone rises into branches, and now the rounds that should be chewing a wheel well are trimming leaves. He corrects, shortens the burst, and the gun stops wandering. The weapon doesn't punish him for going slower. It rewards him with control. Exhibit D is feeding. The M2 is belt-fed, but a belt is not a magic ribbon. It has weight, stiffness, and friction. Drag on the belt becomes drag on the feedway. Drag becomes hesitation. Hesitation becomes a stoppage at the worst moment. When the target is moving, when your team is already committed, when the enemy is testing your nerve. So crews did something that looks trivial until you watch it save lives. They staged the belt. A belt laid in a smooth curve, supported by the lid of an ammo box, feeds like a promise. A belt kinked around a wheel, twisted under a boot, or hanging off a tailgate becomes a trap. That is why the assistant gunner exists. Not to help, but to keep the gun's appetite satisfied while the gunner's eyes stay on the lane. The second quiet rule is exposure management. The M2's strength is reach, but reach invites return fire. The crew learns to keep their silhouettes small. The gun sits low. The gunner stays behind the receiver line. The assistant feeds from the side, not from above. Ammo cans are placed where a man can reach them without standing. The difference between a competent position and a dead one is often a simple angle and a simple habit. Now the mechanical risk that made headspace and timing feel life or death. A barrel change done sloppy. The gun is hot. Gloves are thick. The crew is rushed. If the headspace is too tight, the bolt may not fully lock on a round. If it's too loose, the cartridge can sit wrong, and extraction can tear the case. If timing is off, the gun can fire at the wrong moment in the cycle. Under stress, crews wanted speed. The M2 demanded correctness. That demand looks like weakness only if you ignore what it bought. When the gun is correctly set, it behaves the same in dust, in cold, after rough handling, on a bouncing mount, and in the hands of a crew that just drove all night. Predictability is a form of armor. The third quiet rule is heat discipline. Heat is not a future problem. It is a problem that arrives in minutes. The barrel's temperature climbs. Lubricant thins. Carbon builds. Metal expands. Accuracy changes subtly. First a widening pattern, then a wandering point of impact if the mount loosens or the gunner starts chasing. The M2 will keep firing, which is exactly why crews had to decide when to stop. In many fights, the smartest burst is the one that ends early enough that you can fire again later. Here's the twist. The M2 didn't just protect convoys, it protected tempo. A convoy that can't move is a convoy that gets registered. An ambush that gets held in place long enough will be bracketed by mortars. So the .50's job is often to create a narrow window, 30 seconds, 1 minute, where drivers can punch through the choke point while the enemy keeps their heads down and their hands off triggers. In the lane, the assistant gunner slaps the box lid flat and pulls the belt into a clean curve. The gunner sights on the gap where the muzzle flashes were. He fires short, brutal bursts, not to win the firefight, but to make the enemy choose, stay and be punished, or move and lose the angle. The half-track in the foliage backs a fraction. It isn't dying. It's reconsidering. This is the M2's real leverage. It converts confidence into hesitation. Against a weapon that can reliably rake an opening at distance, the shooter's safest option is often to stop shooting. That is not a kill, but it is control. Exhibit E is mounting hardware again, because recoil is only a problem when it moves something it shouldn't. A mount that flexes turns recoil into dispersion. A mount that loosens turns recoil into a slow drift. The M2's recoil impulse is heavy, but it is consistent. Consistency means you can engineer against it. Thicker brackets, better lock points, steadier traverse. Crews learn to check pins and clamps like they checked ammo. If you ignore the mount, you waste the gun. Now widen the lens past that one lane. The M2 lived on everything: tripods, trucks, tanks, half-tracks, boats, fixed positions. That matters because it meant one training language across roles. The same gunner who understood belt staging on a truck could understand it on a ring mount. The same crew discipline that prevented feed drag in a hedgerow could prevent it on a rooftop in a city. Standardization isn't glamorous, but it keeps weapons firing when units are exhausted. People talk about the M2 like it was old, and it was. But age is not automatically weakness. Age can mean every failure mode has been discovered and answered with procedures and spares. The M2's greatest advantage by mid-war wasn't novelty. It was that thousands of crews had already learned what not to do, and thousands of armorers had already learned how to bring a sick gun back to life quickly. So when the fight shifted from hedgerows to villages, the gun followed without changing its identity. Same receiver, same belt, same ugly reliability, different problem set. And the next part hinges on the place where the M2's reputation was made and nearly broken at the same time. When the enemy stopped being a hedge line and started being the sky, how did crews adapt a heavy ground gun into an air defense answer without turning it into a stationary liability? Stop. What exactly kept the M2 fed and cool without getting the crew killed? And that's where the sky problem begins. So when the enemy stopped being a hedge line and started being the sky, the same heavy ground gun had to answer a new question. How do you point brute force at something that never holds still? The first shock is timing. A fighter at treetop height crosses a convoy's field of view in seconds. By the time a man hears the engine note and looks up, the aircraft is already past the best angle. That meant the M2's anti-air value was never about tracking forever. It was about compressing detection, decision, and fire into one fast routine, like a drill you can do while your pulse is climbing. Exhibit F is the mount again, because anti-air is mostly geometry. A tripod gives stability but limits sky coverage. A ring mount on a half-track gives traverse, but it also gives vibration, blind spots, and the temptation to stand tall. Crews learned to build a sky-facing position the way they built a ground-facing one. Keep the gun free to move. Keep the man small. Keep the belt feeding clean. Then comes lead. On the ground, you walk rounds onto a doorway. In the air, you must fire where the aircraft will be, not where it is. So the trick became simplicity. Tracer helped, but it also lied. At certain angles, you can chase the glow instead of holding the correct lead. The best crews didn't chase. They bracketed. On some mounts, the simple ring and bead sight mattered more than any fancy math, because it gave the gunner a repeatable reference when the target was just a blur. A typical routine was short burst, correction, short burst, letting the pattern build a fence in the aircraft's path. Not a stream, a fence. The M2's heavy bullet carried energy, but its real gift was that it stayed coherent far enough out that the fence still mattered when the target was already pulling away. Now anchor it. Late summer of 1944, somewhere along a supply road in northern France, the sky is clear enough to feel dangerous. A convoy has paused at a bend where the hedges open into a shallow valley. Drivers are impatient. Then the lookout's arm snaps up and you can see it. The tiny black shape, low and fast, dropping toward the road. Nobody has minutes. They have maybe 12 seconds. The half-track gunner swings the ring mount, and the assistant yanks the belt to keep it from snagging on the shield. The gun is already loaded, already set, already staged. That preparation is the entire point. The gunner doesn't wait for a perfect sight picture. He fires 2 short bursts in empty air ahead of the aircraft's nose, then shifts the fence slightly as the plane commits. What happens next is not Hollywood. The aircraft doesn't explode. It doesn't always even fall, but it flinches. The pilot breaks the line, climbs early, or jinks off the road because the space where he planned to be is suddenly full of heavy, fast metal. The convoy's survival is measured in that tiny deviation. This is where the myth starts. People imagine the .50 as an aircraft killer, a magic answer that swats planes out of the sky. Sometimes it did, but what people get wrong is the purpose. The purpose was denial, forcing an attacker to abandon the clean, stable run that makes rockets and cannon accurate. Even a miss can be a win if it breaks the geometry. Exhibit G is ammunition economics. Anti-air fire burns belts at an alarming rate. A nervous crew can waste a day's supply in minutes, especially if they try to draw lines through the sky. The disciplined crews treated anti-air like a fire mission with a budget. They watched for the attack profile, the moment when the aircraft had to commit and fly predictably. Then they fired hard and brief. And heat is still there, now worse. Pointing up means less airflow across the receiver and barrel. A ring mount encourages long arcs and long bursts. Long bursts mean a hot barrel, and a hot barrel is a trap because you can't schedule the next attack. It schedules you. So crews built a rhythm: fire, stop, scan, reset. The gun's weakness as a sustained hose became a strength as a controlled ambush tool. There's another constraint hiding inside that sky story: stabilization. A vehicle mount lets you traverse quickly, but it shakes. Every bump turns your muzzle into a paintbrush. The solution wasn't technology, it was positioning. Drivers learned to stop where the ground was firm. Assistants braced ammo boxes so belts didn't bounce. Little choices, big consequences. The M2 also benefited from something boring and decisive: ubiquity. Because the same gun lived on trucks and tanks and fixed points, units did not need a special anti-air species to improvise air defense. If you had a .50 and the right mount, you had an answer. Not a perfect answer, but an answer you could deploy tonight. The enemy adapted too. Pilots avoided predictable approaches. They used terrain masking. They came from the sun, and every one of those tactics made the .50 less likely to score a clean kill and more likely to function as a deterrent, an invisible tax on the attacker's confidence. So the gun became part of a layered system: lookouts, shouted warnings, vehicles spacing out, drivers trained to keep moving, and gunners trained not to panic fire. In that system, the M2 is not the hero. It is the tool that makes the system credible. But credibility requires reliability, and reliability requires maintenance under the worst conditions. Because once the weather turns and the roads turn to slurry, the M2's true enemy isn't a plane. It's congealed lubricant, frozen fingers, and belts that feel like iron snakes. And the next section hinges on how crews kept the gun running when cold and grime tried to turn every moving part into a stoppage. And the moment the Browning M2 stopped being a big rifle and became a system was the moment crews learned it was allowed to be boring. Boring meant predictable recoil, predictable heating, predictable stoppages, because the stoppages had names and fixes. A belt that sagged at the wrong angle, a feedway that went dry in dust, a barrel that was tightened hot and then seized, or the one that scared everyone the first time they heard it, a gun that fired out of time because headspace and timing had drifted. This is where the myth breaks. What people get wrong is thinking the .50's power made it inevitable. Power was never the hard part. The hard part was taking that power, firing it in bursts all day on a ship deck that vibrated, in a bomber that iced up, on a vehicle that shook itself loose, and still keeping the gun in a state where an exhausted teenager could fix it fast with simple tools. Exhibit A was the operating cycle: short recoil, not gas. In the M2, the barrel and bolt recoil together a short distance after the shot. That movement delays opening until pressure has dropped. Then the gun extracts, ejects, strips the next round, feeds it, locks again, and does it at a pace that matters against a closing target. But the whole cycle depends on two adjustments that sound like trivia until you're behind the gun: headspace and timing. Headspace is the gap that decides how a cartridge sits in the chamber. Timing is when the firing pin releases in the cycle. Too tight, and the gun binds or misfeeds as heat grows. Too loose, and you invite misfires or the nightmare. An out-of-battery event that turns confidence into caution. Wartime crews learn to treat those settings like torque on a propeller. Not optional, not nice to have, but the boundary between a weapon and a liability. So the advantage wasn't the caliber, it was maintainability under stress. Picture a coastal airfield in southern England, spring 1944, wet, cold, working into every hinge. A returning bomber crew is filing past the armors, and one waist gunner is still staring at his hands. His gun jammed during a pass. The armorer doesn't argue. He drops the M2, opens it, and shows the cause like a mechanic reading a spark plug, a link twisted just enough to drag, plus fouling that changed the feel of the feed. Then comes the quiet part. Clear, inspect, set headspace, set timing, hand cycle until the bolt feels smooth. Exhibit B was heat. A .50's energy is a blessing and a bill you must pay. Heat is the bill. In the air, bursts are short, but temperature spikes fast. Oil thins, fouling behaves differently, tolerances shift. On the ground, the temptation is longer bursts because the target is still there, and adrenaline is louder than the manual. But a long burst turns a weapon into a furnace. That's why spare barrels mattered, why disciplined bursts mattered, and why a gun that could be brought back from the edge mattered in the field. Now you can see why the M2's supposed weaknesses kept flipping into strength. Heavy? Yes, so it stayed stable on rough mounts. Older design? Yes, so the procedures were understood and teachable. Manual adjustments? Yes, so a crew could correct drift instead of hoping a sealed system forgave neglect. And it worked across roles that weren't supposed to match. On a ship, the M2 was a defensive rhythm instrument. A twin mount could sweep a sector, force an attacker to climb or break, and buy seconds for bigger guns to react. On a truck or half-track, it was an anti-material tool. Engines, radiators, ammo boxes, the fragile parts that make machines stop being machines. In a bomber, it wasn't a sniper rifle. It was an argument delivered in a cone of fire, meant to raise the cost of a clean approach. But there's a truth that gets cleaned out of many retellings. The .50 was not magical against everything. Range, lead, stability, and training still ruled. A vibrating mount or a belt contaminated with grit could make a powerful cartridge miss cleanly. The M2's value came from reducing the number of ways a mission could fail. Planners could treat it as a constant, and in war, constants are rare. So here's the central question this story has been building toward. Why did one design survive every environment it was dragged into? Because it was built around the ugly reality of war, not the clean reality of a test range. It tolerated dirt. It tolerated imperfect lubrication. It tolerated mounts that weren't perfectly rigid. It tolerated crews who learned in a hurry. It could be installed on almost anything because its recoil behavior was consistent and its feed system could be adapted. Most of all, it was maintainable. It did not demand genius from its operators. It demanded routine. And routine changes decision-making. It changes whether a convoy commander believes his gunners will be ready at first contact. It changes whether a pilot takes a risky approach. It changes whether a ship captain believes his deck crew can throw up a wall of fire fast enough to matter. So if you want the verdict without romance, it's this. The M2's weakness was never that it was heavy or old or manual in its adjustments. Those were the costs that bought reliability. The real strength was that it turned high energy into repeatable work, and it let tired human beings keep that work going. Perfection wasn't the point. Availability was. And availability, multiplied across thousands of mounts, changed the shape of risk for the people who had to move, fly, land, and survive. In the end, the story resolves into three clean lines. Power matters, but power without procedure is just noise. Reliability is not a trait, it's a maintenance rhythm you can sustain. And the weapons that change wars are often the ones that keep working when nobody has time to be clever. Thanks for watching. If you want more World War II stories told through real constraints and mechanisms, subscribe. Link is in the description.